Hello, my little mathematicians. Today, I'm going to help you with your notes on packing with unit cubes. So, first off, let's go ahead and look up at the top. It says, Mr. Wrangle was putting away ornaments from his Christmas tree. Each individual ornament is secured in a box, and then all the ornaments are placed in a larger storage tub. Discuss the different ways that Mr. Wrangle can determine if the ornaments will fit in the tub. So we're going to start by using the images below to label the dimensions with the number of cubes in each rectangular prism. Then count the volume of the unit cubes. And then to kind of help us visualize this, a lot of the ornament boxes are kind of gridded out like this, so then the ornaments don't break. Okay, so let's go ahead and see how this works. So first off, each of these boxes, let's go ahead and count each of those as, like to find my length, this is 1, 2, 3, 4 units long. And then my width is 1, 2, 3, also 4 units long. And then my height is only 1 unit long. Now to find the volume, if you guys remember, what's the formula? It's area of the base times the height. Well, the area of the base is a rectangle, so that's length times width times your height, right? So we said that our length was 4, our width was 4, and our height was 1. So if you multiply that, 4 times 4 is 16, and 16 times 1, that's 16. And then we don't know the particular units, so we're just going to use U for units. And it's units cubed because it's 4 units times 4 units times 1 unit. And units times units times units is units cubed. Okay, so the volume of that guy is 16 cubic units. Okay, let's look at this one. Can you tell me the length? Yeah, hopefully you said 2. What's the width? Yeah, 4. Now, if for some reason you're like, I said this was the length and that's the width, who really cares? Okay, because 4 times 2 is the same as 2 times 4, right? It's like, don't get caught up on that. This is the height, and that's what? 2. Yeah. Okay, so again, we're still finding the volume. So length times width times height. We have 2 times 4 times 2. Well, we know that 2 times 4 is 8, and 8 times 2 is, 16. So you should have gotten that this was also 16 cubic units. And you're like, wow, these look kind of different, don't they? But they both can fit 16 cubic units inside. Let's go ahead and now ask the question. Use the images below to label the dimensions with the number of cubes in each rectangular prism, and then count the volume of them. Kind of the same thing, except they told us that this time they're representing a half of a unit. So there's 2 ways I could do this. I could say, okay, then that's half and half. There's 1, and half and half. There's 2. I think that can get confusing as I go along. So what I'm going to do is I'm going to say 1, 2, 3, 4, and half of that is, it's half of 4. Yeah, 2. And then 1, 2, 3, 4, half of that would be 2. And then 1, what's half of 1? Half. Okay. So then volume equals length times width times height. Well, my length was 2, my width was 2, and my height was a half. Well, 2 times 2 is 4, and 4 cut in half is 2. So you have 2 cubic units for this guy. Okay. Notice how this was actually the same, right? Like it looks like a 4 by 4 by 1, but I cut each of those in half. So then can you say, oh, well, since I cut each one in half, I'm just going to cut this in half. Did that work out? If I were to cut 16 in half, do I get the correct volume? I don't. So I can't do that, right? Because essentially like you're cutting each value in half. So like you're actually taking the cubic root of it, which we don't know how to do yet. So it's better if you just cut each individual unit or dimension in half and then find the volume that way. Because again, as you can see, oh, if this is the same, we just cut each unit in half, I can just find the volume of the normal one and cut it in half. That trick doesn't work. Okay, so for this one, okay, it looks like it's 2, but each one's representing a half, so it's really only 1. And this guy's 4, well, half of 4 is 2. And this guy's 2 tall, but half of 2 is really only 1. Okay, so then when I go to figure out this volume, length times width times height, you have 1 times 2 times 1. Well, 1 times 2 is 2. 2 times 1 is still 2. So this is 2 cubic units. Okay. And then again, like we knew that these would be the same because just like, these two were the same, we're essentially doing the same thing, right? Okay, here. It says, Mrs. Sebastian asked students to estimate how many cubes could be packed into the rectangular prism shown below. So you have this rectangular prism and you want to know how many of these cubes could fit inside. Like think of it as each of these are like little ornament boxes. So what process do you think her students should take to find that out? What did you come up with? Yeah, they could compare the dimensions and like try to just visualize it. That okay, yeah, you could do that. Is there a way to do it like mathematically? Okay. So yeah, based upon that, like I mean, if you kind of like visualized it, oh, it looks like two could fit there, and then going back. But the thing is, not all things are drawn to scale all the time. So you always want to try to like work it out mathematically. So if you found the volume of each cube, and then you found the volume of the prism, and then you took the volume of the prism and you divided that by the volume of each cube, then you could figure out how many could fit inside, right? So let's go ahead and actually try that on the next page. Okay. So if we go ahead and turn the page right here. Okay. Again, so kind of writing that out in words up at the top. It says first, you need to determine the volume of both that larger prism and the smaller prism, right? So you want to know this guy and this guy. Then you're going to divide, okay, divide the volume of the larger prism by the volume of the smaller one. So you're going to take this one and divide it by this, and then that'll tell you how many can fit inside. So, okay, it's still dealing with a rectangular prism. So length times width times height. And since they told me that each one is a half and it's a cube, we know that they're all a half. So the length, width, and height are all half. So when you go to multiply that out on top, 1 times 1 times 1 is 1. On bottom, 2 times 2 is 4, and 4 times 2 is 8. So this is 1/8 cubic units. Now to find the volume of the larger prism, okay, it's still a rectangular prism, so length times width times height. And the length here is 5/2. The width is 1/2. And again, if you switch that this was the length and this was the width, who cares? Like 5 times 2 is the same as 2 times 5, right? Okay. And then the height is 3/2. On top, you have 5 times 1 times 3. Well, 5 times 3 is 15. On bottom, 2 times 2 is 4, and 4 times 2 is 8. Okay, so 15/8, or I mean, if you want to simplify that, 8 goes into 15 once with a remainder of 7. So 1 and 7/8 cubic units. Okay, so these are saying the same thing. This is probably what I would write the answer of my volume as, is like this, 1 7/8 cubic units. However, I probably want to use this when I go to do my division because it'll be easier. So I'm going to take the volume of my bigger one, 15/8. I'm going to divide it by the volume of each cube, which is 1/8, and see to figure out how many of these can fit inside. So remember when we're dividing with fractions, we do keep, change, flip. So I keep the first fraction the same, change division to multiplication, and flip that second fraction. And now, look how nice. These 8's can cross cancel and become 1. And then on top, you have 15 times 1, which is 15. And on bottom, 1 times 1, which is just 1. So we get an answer of 15. So that means that 15 cubes can fit inside of that larger rectangular prism. Okay, I want you guys to go ahead and try that bottom one. So pause the video, try it, and then unpause it and come back. Okay, so you paused it, you did the problem, and now you're back with us. Okay, when you did this, yes, I want you to write the formula so you get in the habit. Volume is length times width times height. And since it's a cube, all three of those dimensions are the same. So 1 times 1 times 1 is 1. On bottom, 3 times 3 is 9, and 9 times 3 is 27. So you have 1/27th cubic units for the volume of that cube. Okay. And then when you did the volume of the larger one, let's see, hopefully you got this right. Okay, this one was 4/3. This one was 3/3, which is, yes, just one. But it just makes it easier for us to multiply, I guess. Okay, and then 2/3 here. Technically, yeah, I could multiply this out. Let's see. 4 times 3 is 12. 12 times 2 is what? Yeah, 24. Okay. And then 3 times 3 is 9, and 9 times 3 is 27. Okay. I could reduce that by 3, right? If I reduce that by 3, I get 8 ninths cubic units. Okay, so that would be the volume, but I mean, that's an acceptable volume too. So now when I go to divide it, you take the larger one, which was 24 over 27, or let's redo the problem down here. What if I did 8 ninths? Okay, and I divide it by the smaller one of 1/27. Okay, I should get the same answer because 8 ninths is equivalent to 24 over 27, right? This one's nicer, the unreduced one, because when I do keep, change, flip, look what happens. Those cancel and those cancel. And you get, hey, 24 times 1 is 24. So 24 cubes can fit inside. Versus this one, I do keep, change, flip. I have to do a little bit more work. These cross cancel by 9. So 9 divided by 9 is 1. And 27 divided by 9 is 3. And then on top, you have 8 times 3 is 24. And on bottom, 1 times 1 is 1. And 24 over 1, it's still 24 for my answer, right? It's just that one looked a little bit easier. Either way, you decide to do it, it's fine. You still get 24 cubes. And then depending upon your teacher, if they want it fully reduced or not. 8 ninths cubic units or 24 over 27 cubic units for that larger prism. And then how many can fit inside? 24 cubes. Hopefully you guys got that right. If you did, congratulations, my little mathematicians. You are masters at finding the volume of rectangular prisms.